speaking German?
No, today I'm speaking English.
You are speaking English today, okay. So, okay. I thought your talk will be tomorrow, but you have it today. Tomorrow we have the Agile track or the Agile day, but your talk is about agility too. So, 2000, as Kent Beck came with XP, so I was happy, yes, to try the things from the scratch, to write the test first, and to write the code after that. Nice thing. You don't like that?
I do like it.
So, what is the problem?
The problem is that Agile development focuses on building new software systems. It helps you create new software and doesn't provide you a lot of support in finding existing software that could do the job that you need.
You mean with your talk, you will help me today to understand how I can reuse existing software the Agile way?
Exactly. Well, within an Agile project, how you can reuse existing software.
Okay.
That's the goal.
Okay, I will be happy to hear that.
Okay.
Thank you very much. Well,
all right. Thank you very much. So, as we just discussed, yes. I need to hook my computer to the. There we go. That's very clever. There we go. There we go. Good. Okay, let's start again. As we just discussed, my talk today focuses on the intersection between three paradigms or three best practices for software engineering today: test-driven development, software reuse, and agile development. And the technology that I'm going to show, although it's quite immature at the moment, may, I think, point the way to how people will develop software in the future. And it may already be something that you find useful in your own development projects. Oops. So I'm not going to spend a lot of time talking about agile development. I'm sure you all know what it is. In fact, I'm sure most of you are actually using it in your development projects today. And software reuse is an older idea. Software reuse was a hot topic in the 80s and 90s, long before agile development was a hot topic. Software reuse aims to accelerate and improve software engineering by finding and reusing components that already exist, so that you don't have to build new applications from scratch. And so in a sense, agile development and software reuse share the same goal. They want to help you construct a new application with a given level of quality quicker and more cost effectively. But today, the two are rarely done together. Certainly agile development, in the form that it's promoted today, Scrum and so on, or even extreme programming, doesn't focus on reuse, doesn't include practices and heuristics and so on for finding existing components that you could reuse. And so we think there's a synergy that can result from trying to use the two together. And so here we got the famous kind of cycle that I think Kent Beck popularized with extreme programming that characterizes the difference between an agile way of developing software and the classic kind of waterfall way, which is, of course, you want to analyze a little, design a little, code a little, test a little, and when you've got one increment, you do it again and again and again and so on. And of course, what we want to do is to change code to reuse. We want to analyze a little, design a little, reuse a little, and test a little, right? Of course, we expect to code a little as well, but we want to bring reuse into the mix. That's the goal. So let me just say a few words then about reuse, right? As it was understood in the golden years of software reuse research. In the 80s and 90s, reuse was the hot topic that you could use to get lots of funding for projects and so on. It really was a hot topic which kind of died out because it didn't deliver on the promises that were made. And of course, the idea is very simple. The idea is very simple. It would be nice if we could build software applications in the same way we build, for example, laptops and computers, right? 90% of the components of that laptop there are off the shelf and are put together to create a new variant of a laptop, a new product, right? If we could do that with software, that would revolutionize the way we build new applications. And the idea goes right back to the famous conference in Garmisch-Partenkirchen where the name software engineering was coined. McElroy there proposed the idea of software components and the idea of having markets of components that people could use to buy off-the-shelf components. But as I mentioned, it didn't take off. It's not something that people put a lot of emphasis in these days in an explicit way. And it nevertheless has a lot of promise, we believe. So what do we mean by components? Well, we need to get that out of the way before we carry on, right? Defining what a software component is a topic that academics can debate for many months. They have done for many months. There's many different definitions of what a software component is. But for us, it's very simple. It's anything that has an interface that you can call. Anything that has operations or methods or functions, whatever you want to call them, that you can call. Right? So that includes classic classes from programming languages. It includes APIs. It includes web services. Anything that basically you can call via operations. We're not interested here in little snippets of code, like a couple of lines here and a couple of lines there. We're interested in complete modules that deliver the functionality, that implement an interface. So, why did reuse not take off when it was such a hot topic in the 80s and 90s? Well, there's three main reasons. One is that there just were not a lot of components around at that time. Right? Some of the classic papers from that era on software reuse describe projects where they were happy to have 200 components. Right? Secondly, the technology for finding components was rather crude. Right? It was often just based on matching strings in the textual description of the component, right? And so basically what that meant was that the result set had had very low precision, and a lot of the things that were returned weren't what you wanted, and a lot of the things that you would want were missed. So it had it didn't have high precision, and it had low recall. And last but not least, what that means is, right, is that in practice, right, software engineering is a high-pressure activity, right? You're always forced to make trade-offs and create a balance between the quality of what you're delivering, the amount of functionality you're delivering, and the time it takes to deliver the software. And if reuse doesn't offer the right balance between effort and risk involved in trying to find reusable components and the payback, then people just aren't going to do it. And that was the basic problem. The trade-off was just not worth it. People just found themselves putting too much effort in, and most of the time they had no benefit. So why waste time doing something that hasn't a high chance of providing a benefit? Things have changed. Things have changed a lot since the turn of the millennium. First of all, there's lots of components now, right? There's lots of components, and everybody has unlimited internet access so that they can find these unlimited components. You have open source. The open source movement has taken off. There are vast repositories of software out there that you can access if you want to. There's also the web service revolution. So a lot of software is not now available as classes. It's available in normal programming languages. It's available as online invocable services. But still, that's functionality that you could reuse rather than building from scratch yourself. Secondly, the technology for finding components has significantly improved. For example, there are some very powerful indexing engines like Lucene, which Lucene is an open source product that can index all kinds of textual documents. But at our university, we've adapted it for indexing software documents, right? And enhanced it to recognize the meaning of methods and parameters and so on. So the recall and precision of the search algorithms is much better. And so now you're starting to get a different balance between the risk involved in trying to find reusable components and the effort it takes to do so. And the technology I'm going to show you now over the next few slides is trying to further improve that balance so that it makes more and more sense to consider reusing existing components. In fact, we have two technologies which I'm going to briefly talk about. One is Merobase, which is a large software search engine that's online now that you can use. And the other, which is the main focus of my talk, is an Eclipse tool called Code Conjurer, which uses Merobase to try and offer you reusable components with minimum impact on your usual work so that you can benefit from software that's existing out on the internet or more specifically as indexed by Merobase. So let's just say a few words about Merobase. This is not a talk about Merobase. Could spend a whole talk, of course, focusing on Merobase, but I'm just going to say a couple of words about Merobase. Merobase is one of the largest software component search engines online at the moment. This is its old interface here. I'll show you the new one in a minute. It's got more than 10 million components of many different kinds of languages, mainly Java. It's also got web services. It's now got Android apps. In fact, we have an offshoot called MeroDroid, which is specifically focused on Android apps, so you can find components for Android apps. And we have more sophisticated search mechanisms than was available in the first generation of search code search engines. So in addition to the regular keyword where you just type in a string and you see if you can find components that contain that string, you can also type in names where the meaning of the name in the code is matched. So you can look for the name of a class, you can look for the name of a method, and so on and so forth. So rather than just having pure strings, you can say, I want a class with this name, I want a method with this name. And then the best recall and precision is provided by interface-based searches, which is unique to Merobase, which is where you type in a little interface, the name of the interface, the method names, the parameters, and so on, and it looks for components which match that interface. Once you find them, you can, for example, execute services that you find using Merobase. It gives you a lot of metrics about the components, and so on and so forth. So just to give you a quick feel for how Merobase works, this is a little scenario. It works like a search engine in the way you would expect. So there you go. There's the old Merobase interface. And let's say I'm looking for, I'm building a system where I need to calculate mortgage repayments, monthly repayments, and the total payment at the end, right? So this is the interface that I'm interested in from my perspective, right? If I type that into Merobase, then I will get a list of results like this. Here they're all Java classes, but it'll find any kind of code that's in the index. And then if I find one that looks interesting, I can kind of zoom in a little bit and see what its method profile is. And if I really find it interesting, I can click on it and go in and get more information. I can look at the code, I can get metrics about it, and so on and so forth, right? So that's the classic kind of searching for code, like Google for code, if you like, the way you would expect a search engine to work. And this is the second interface to Merobase, right? And the reason I showed this one is because it also shows that with Merobase you can, you have a lot, various ways you can filter the search. So we can also, here you can say whether you're looking for binary code. We can find binary Java classes. We can find assemblies in .NET and so on. There you can look for the language. Here you can indicate whether it's a class, whether it's an interface, whether it's a package, whatever, and so on and so forth. Here you can say whether it's part of an EJB, whether it's part of an application, whether it's part of an applet. You can indicate options for the licenses that you're interested in. You can focus on particular projects if you want, or particular repositories, and so on and so forth. And so, just to finish off my little summary of Merobase, the new generation of code search engines like Merobase provide significantly better results when you search for code than the first generation. So here's a table from a publication that I didn't want to show the whole table, but we did experiments to analyze the precision, the average precision. Signature-based search is not very precise. What that means, signature-based search just looks for, if you type in a method, passing in 2 integers and returning and then getting an integer back, for example, then you find things with the same signature. And it's not very often that what you find is what you want, right? String-based is the old, just look for a string that you type in the text. Name-based is where you take the semantics of the string and work out whether it's a name of a class or the name of a method. That's getting better. And interface-based is the best. That's unique to Merobase. 54% of the time, or 54% of the results, are actually what you want from a subjective judgment of what matches the query. Okay, so that's not bad, but it's not good enough, really. That is not good enough to change the balance so that everybody's going to start going out there and spending time trying to use Merobase to find existing components rather than develop them themselves. We still need to do better, and in particular what we need to do is we need higher precision, so we need to raise the likelihood that the results are what you actually want, and we need to do that by taking the semantics into account, right? We can't just do it purely on interfaces. We need to start to deliver results that take the functionality, the semantics of what the component is meant to do into account. Okay, well, you might think semantics, formal methods, defining semantics, in operational or declarative ways and using logics. And you can do that, but you can't get very far because the complexity of approaches that use formal definitions of semantics is just too great. But there's another way of defining the semantics of components. In fact, people use it all the time in agile development, test-driven development, right? You define the semantics of what you want up front in agile development, right? What's the best practice is to type in the test cases first, and then to create the code that satisfies the test cases. So if you've got upfront test cases, why not use them to improve the precision of your results? And in fact, if your test cases are exhaustive, right, then you will only get things back that you want. So if your test cases that you've defined are your definition of acceptance, pass the test case, the component is good enough, and you can search using test cases, then you get 100% precision. And so our engine, now our Merobase, supports test-driven searches. Well, very simple principle. Basically what we do is we do, well, first of all, you identify the interface you want, right? Okay, so we use interface-based search as the foundational search, right? You define the semantics of what you want as tests. You can do it in JUnit, you can do it in test sheets or whatever. Then Merobase finds an initial list of candidates using interface-based search, and then it fetches each one from its location, builds it so that it can be executed, and then filters out those components that don't pass the test. So at the end of the day, you have components that pass the tests that you have input. Okay? So it only delivers components that pass your tests. So this is the last slide, and then I'm going to show you 3 videos, right, that give you a feel for how this works, right? So let's imagine that let's build on this mortgage calculator example, right? Here we are. This is the interface what we want, that we're looking for. We want, this is written in Java, but it doesn't matter. It's the interface that matters. It's a component called mortgage. And we, obviously we need a constructor which takes in the rate, the number of years, and the size of the loan, and then it returns the monthly payment that's necessary given these inputs and the total payment. Now, by the way, I forgot to mention, interface-based search isn't restricted to exact matches. Right, exact matches will come at the top of the result set, but it also, the Merobase uses a lot of clever tricks to find similar names, to break long names down into their core terms and so on and so forth. So you don't just get things that are exact matches. That's important because that significantly improves the effectiveness of this technology. So if you were doing Agile development, right, and if you're doing it according to the book, right, you would write test cases first. Here are a couple of examples of test cases. So I would, here's the test. I'm creating a new mortgage with some input values for these parameters, and then I have an assert equals. I'm saying that if I ask for the monthly payment on the mortgage that's been calculated, that's been created with these parameters, I expect this value to within a precision and an error boundary of that size. And then I can do another one, and I can do another one, right? And the thing is, what you can do when you have test-driven search, of course, is you can look for components that perhaps pass those tests before you actually start to build it yourself, or as you're building it yourself. So let me now show you the first of my little videos. What was meant to happen, like the last speaker, I was meant to press now the button and it would spring into life, but because my movies are in QuickTime, I couldn't get PowerPoint to do it. So I've got to now go. Sorry about this. Oh, that was right. Bear with me 1 second. Oh, sorry, here. Right. So here we go. Sorry. That's not the video I'm hoping to show you. I've been practicing this all afternoon, and it's worked. Okay, so why are we not seeing this video all of a sudden? Sorry? I mean, it must be something with a. Yeah.
There's 2 monitors that can only show.
Okay.
Is the
Should I get rid of one of the monitors?
Yeah, just switch on
Yeah.
this one.
Yeah. That's that one. show the video. Okay, right, let's just go to about here. Okay, so here's the video. And now we're starting from a normal Eclipse environment, and I'm going to start by writing the test. Okay, I haven't got anything to do with mortgage calculator yet. I'm writing the test. Here we go. So I'm creating a test in the normal way I would with Agile development, test-driven development. I'm calling it mortgage calculator test. I obviously have to set up the test. Then I have to type in, of course, the first actual test, which is checking functionality and what's returned against a particular set of input values. And of course, it doesn't work because I haven't got any code yet. So the simplest thing I can do, right, this is going to improve over the next few videos, but the simplest thing I can do is I can copy that test, right? I can go to Merobase. We do. It's the next video. So now this is showing the capabilities of Merobase. So now we have to log in, and then what we do is we basically paste the test into Merobase. This is the latest interface to Merobase. We put it in there, and now we do a search, right? And Merobase is coming along, and it's giving the initial results, and now it's testing them. We can see that it's telling us that it's testing them, right? You can also ask just to get an email with the results at the end if you want, but that could come several minutes later, right? But now, what it does is it takes 30 at a time, right? And you can see that none of them passed. We didn't find anything that passed the tests. Why not? Because the first test is so generic, so to speak, that it catches all kinds of components. It's not specific enough, right? So what we're going to do now is we're going to, we added there a second test, right, which defines more of the interface. Merobase works out the interface from the tests, right? And now it's doing it again, right? And now you'll see, look, the second one worked. So that is a component out on the internet somewhere that passes the test, right? And so I can look at it with Merobase, and I can, you know, analyze it a little bit, see if it looks reasonable, and then in this primitive first version, I can just copy it and paste it in. But notice it's called lone calculator, right? Merobase finds things which are rough matches, not exact matches. So this is not going to work, right? It's not going to work because it's called lone calculator, right? It doesn't have the right name. So I can attempt a little bit. It's importing things that I don't import yet, or I don't even know where they are yet. I can try and change the name to do some fixes, but it's not very convenient at this time, right? There's other errors that the mortgage calculator test that I wrote is calling methods that don't exist in that class, and so on. So, okay, oops, that's the second one. I need to stop that. Okay, there we go. So, notice we've made some progress because we can find components that fulfill the functionality that you've defined. No, that's it's coming on now. Let's go back to the presentation for one moment. So we can find code that matches the functionality that we've said we wanted in tests. Okay? But it's not very convenient. So as you already indicated, it would be nice if there was a plugin that gave us Merobase functionality directly at our fingertips within the Eclipse programming environment. And that's what Code Conjurer basically does. Right? You can actually call up all of the Merobase functionality from within Merobase. You can easily just type in any kind of search, but we're interested now in test-driven search, okay? So Code Conjurer is an Eclipse plugin which seamlessly integrates Merobase-driven search into the Eclipse development environment. so it does code-driven search. You can notice that we defined our interface in Java, right? So you can give Meribase classes that have been partially written, and it will find code that matches what you've partially written, and so on and so forth. You can give it JUnit tests, and it will find things that satisfies those tests. The last video I'm going to show you is this unobtrusive background recommendation, which is an important step as well. It can do dependency resolution, right? So one of the things is when you find a component, you need to also find what it depends on. That's non-trivial, but Meribase can do that now. It can recommend interfaces. So if you are using a component, you can find out what interfaces that component should be using. It gives you a lot of metrics. You can find a lot of metrics about components. And what it does do now is it adapts classes in the index so that you can test them. So let me go back now to my second video here, which is now Code Conjurer. Yeah, here we go. So now we're starting with the same where we left off before. We've gone back to the single test, right? It's the same example as we had before, right? But now you can see we've clicked the button there, and Code Conjurer is now testing, right? It's now doing the testing here, okay? And it's the same example as we had before, so it fails, right? None of them were passed, right? So now I've added a couple more tests, right? And I kick it off again. Testing's in progress now, right? So I kick it off again. And here we go. And now look, what we've done is, that's the one component we found before, but now it's also been adapted, right? Remember it was called loan calculator before. Meribase has created an adapter, right, which adapts the found component to what we want, right? So we can look now, there we're going, and this is the found component, and this is the adapter that's been created automatically, right, by Meribase, okay? And so we found something that does what we want, right? It would be great if we could reuse it. Well, so let's just delete the old class that we did from the last video, right? And let's take the class that we found and just drag and drop it in as our implementation, right? Well, it doesn't work again, right? Because it's called loan calculator, okay? So that doesn't work. We already realized that that was a problem. So let's delete it again. That didn't work very well. This is what Meribase Code Conjurer allows you to do. You can pull the adapter over into your project, and as part of pulling the adapter over, the code class itself goes over as the adaptee, and now everything works, right? Here we are. This is the test, which now works 100% because it's calling the adapter, right? If we do the test now, it works 100%. And all we did was drag and drop the adapter over to the... that's the one I want to stop. Oh, I didn't want to do that. I want to stop. Okay. So, what Code Conjurer did, it let me drag the adapter into my project, and then automatically it brought the discovered component as well. So with one or two clicks, right, I got in my project a fully working implementation from the internet, right, and it works, and I've tested it. Okay, so I think that that's starting to change the balance, right? It's not much effort to find components that do what you want, because they're out there. I think I can show you that they're out there. We have many examples where you can find things that are out there. The problem is that that was that one we just wanted. The problem is, it's still very distractive. It still distracts you from your normal work. I mean, who wants to sit there and watch kind of every 5 seconds, you know, a result of a test come up? You don't want to do that. You want to get on with your work with minimal distraction and disruption of your normal work. So what you want really is for this searching to go on in the background, right? So that you're working away, doing your development, and every now and then a little thing pops up and says, oh, by the way, right, you're working on a mortgage calculator, here's one that works, and it passes all the tests that you've defined so far, right? It doesn't happen very often, right? It doesn't happen as often as normal search results, right, where you get lots and lots of results, but they don't do what you want. It happens less frequently, but when it does happen, you've hit the jackpot, so to speak. Right? Because you've got code there that does what you want according to your tests, and you can reuse it if you want to, right? So what we have then, this is just the Code Conjurer homepage, and this kind of highlights its main features. We've already shown test-driven development. I've mentioned automated dependency resolution. It does give you help in doing these little fixes to change names and stuff, but it also supports proactive reuse recommendations. That's what I'm going to show you in the final video. But at the moment, the proactive reuse doesn't work with test-driven search. It did in the past, but the trouble is it was too much. It placed too much demand on our Mero-based servers because we can't stop searches at the moment. Once a search has started, it has to finish. That's something we can fix when we have time. Then we'll be able to put proactive reuse recommendations back in with test-driven search. At the moment, what I'm going to show you now, it does proactive recommendation, but only on interface search. So it's not the optimal combination, right? Fortunately, I didn't have it available with the current version of Mero-based. But you can easily imagine what it would be like, right? It's basically combining what we've just seen, where the results that are delivered are the ones that pass the test, with the ability to drive it in the background. So what does that look like, driving the searches in the background? So go back to the last video. I'm sorry that I didn't get it to work so smoothly as... Oh, there it is, up there. This is a different example. This is an example where we're looking for, where we want to build a tokenizer, right? So there we are. I want a tokenizer, which takes a string and breaks it down into its tokens. Okay, so here we go. I'm going to start coding in a minute. I'm switching on the reuse agent, which is the background agent which is going to give you recommendations. So what I'm doing is now I'm going to start typing in what I think I want, and the engine is watching, the agent is watching, and the moment an interface is defined, it starts searching, right? Right, and these are all things that potentially match what. Notice that it started before we even finished typing our first line. Now that we've defined our interface better, it does a search again, right? And I can, if anything's interesting down here, I can go and look at it, right? Here we found a method. We can look at some of the other methods of that class, right? And if I like it, I can say, well, I'll copy that method. Let's copy that method, right? And this is not test-driven. Two together would be ideal, of course, right? So here we go. At some point we're going to copy it. Oh, here we go. There we go. That's how we copy it in. So we just copy it in there, and it goes into our current implementation, right? But notice that every time we do an event which gives further information about the interface, the agent is looking again, right? And so now we can. So it's a kind of a convergence procedure. So now we've got new recommendations based on where we are so far. And now I can, again, look through, and here I'm now copying a complete class. I found a complete class which does what I want, based on interface-based searches. And so there we go. within a few seconds, I've got an implementation. Okay? And there it is. I'm just browsing through it now. Okay, so that's basically, that's it. Okay, so that's the video that we should have played. So that's it. So what have we got here, right? What have we got here? There's many questions about how one could potentially use this, right? And and also obstacles. So first of all, many people will be reluctant to borrow code off the internet and put it into their software. But they might put it into a prototype, right? Or they might use software that they found that does what they want as something to base their own design on, and copy the design rather than copy the actual code itself. Depends on the license, of course. There's a lot of licensing issues here, and so on and so forth, right? But the technology is potentially quite powerful, because the engine, of course, in the background, Merobase is doing a lot of work, right? But it's making it very easy for the developer to be given options. And of course, with that last video, right, there again, we showed you lots of components being found and shown, and because we, of course, want to show you how our Code Conjurer plugin is doing great things and working hard. But of course, usually you'd switch that off, or you just have a little, you know, a little flag that shows you when there's something interesting. And the idea, of course, is that the background agent will be combined with test-driven search, so that really you should only divert yourself from your normal development activities when there's a component that's been found that does what you want according to your test cases. Okay? And so, I don't know whether I've convinced you that this fits into, this has an interesting relationship to Agile test-driven development because of the fact that you develop tests up front. So if you've got tests up front and you can find code that you know, matches those tests, I'm sure there's interesting things you can do with that code. If not, find what other methods you should consider in your class and so on, right? So a bold claim is that it's the key enabling technology for integrating reuse-oriented and agile development. This is open source. If you go to that website, you can download Code Conjurer. It's open source. You can contribute to its evolution. The Merobase search engine has an API, so you can adapt your own tools to just issue search requests to Merobase and get back these search results. And what's very interesting is that a company can quite easily have their own Merobase, right? Our Merobase crawlers, we just need to give them a list of repositories inside a company's firewall, and they will create a single virtual repository that's searchable with these powerful search algorithms, which is a single virtual repository of all the code. Now, if you're a big company which has got code all over the world, right, that can be very interesting. And last point is it changes the equation again a little bit more. Because if you're searching and getting results from your own company's code, then the obstacles to reusing it and your doubts about its quality and all those things change again. And the trade-off between the value of reusing that code and you spending effort building your own code and testing it and taking out the bugs and all the rest of it is starting to become interesting, I think. Okay, thank you very much.
Thank you very much.
Are you convinced?
Let me tell you something. It is really the interesting talk I had today. Thank you very much for that.
Okay.
So, I have many questions about that, so I'm coming from the XP side, you know, development. Yes? But I will take the place for the other people now. And do you have? Please.
Pretty impressive. My question would be, in Agile development, you usually don't have your tests up front as a whole. You test your next feature that
Yes.
you implement.
Yes.
Now, when you continue on your features,
Yes.
there's one step of someone and two new feature requests.
Yes.
What if your chosen component doesn't fit this new feature?
Yes. You see,
Is there some kind to make contact with developer and share efforts, or do I need to write my whole thing on my own again?
You see, I mean, what this technology can do for you right now is to give you options, right? And to give you options with minimal effort on your behalf. So what I tried to show you there was that, you know, as you very correctly pointed out, that typically when you're doing Agile development, you don't write all the tests first, right? You write one little test and then do a bit of coding, and you iterate backwards and forwards. And at the beginning, you don't find components that really are very useful, right? So there's not really, I mean, my judgment about when things will become interesting is that you don't really want to look or spend a lot of time looking at suggested code until you have got quite far down your list of components, right, of your tests. You can have a look to see what's coming back, and I think you can get hints about even what methods you should be thinking about and so on and so forth. But I think that if this technology becomes really, widely available, it will change the way that the order in which you do tests and the order in which you do Agile development, because it will change the benefit that you get from focusing on writing all the tests first rather than developing the code in a cycle. I don't know if that answered your question. I mean, the point is that we're only at the beginning of exploring how to offer this technology. So we're very interested in feedback, by the way. If anybody really tries this in their, you can try it now, it fits into Eclipse. If anybody tries it and can give us suggestions and say, oh, that's not very good, we like this, we're happy to do that.
And my question is also linked to the evolutionary aspect.
Yes.
And not to the evolution of my own software, but about the evolution of the component or code I copy into my code base.
Yes.
Do you have any plans, any concepts, how you can solve the problem that the person who has originally developed the code, that he updates his component, fixes some bugs, or provides new functionality? How can I get informed about that?
So, I mean, first of all, if you do a cut and paste copy, then you are no longer dependent on what he does in a sense, and you've saved yourself a lot of work, right? And it is a lot of work to get algorithms correct. You know, it is a lot of work. Even the mortgage calculator, you know, to get it correct. So that's the first point. The second point is we're trying to build a community around Merobase so that people can publish software, especially with Android. That's why we're doing Merodroid, because we think the community of developers around Merodroid, around Android, will be interested in putting their software in a community, in a you know, what's the word? Community. But does that make sense? A community. So you can upload your software and other people can see your software and find your software, like Facebook, but focused on code.
Like Git,
Huh?
like Git on Garrett or something like that.
Could be, yeah, similar.
Something like that.
And then you can keep a contact with the individual and keep an eye on what's happening to their original component if you want to keep using that original component.
What was the reason that you showed more the concept of copying the code instead of including a library that can be managed and evolved, and I can better exchange the library when it's evolved? It's like I'm working with, I don't know, Apache libraries or libraries published in Google Code and etc.
Simply because that's where we are at this point in time. It's the simplest thing to start with. once you've found interesting code, there's a long list of things you can do, right? So our problem in our Lehrstuhl at the moment is not thinking of things to do, it's finding the manpower to do a fraction of them. Because you can do so many things with this, right? And we just don't have the manpower to do a lot of them. So as I mentioned, we did have test-driven search and proactive recommendation working together. And we can still do it, but we can't offer it to the public yet because it just crashes our servers. So, but that's just something that's a fixable thing if you know, if we had the manpower and the resources.
Any questions? The last one?
Have you considered, as you are also offering this technology for binaries and web services, to gain more trust that you build in a system that people can maybe rate those libraries or comment on them, or maybe it's like a social system?
Yes, that's what I meant by a community. Yes, a social system. That's the word I was looking for. We want a social community based on top of this ability to find things could be very, very powerful. And the final idea I want to mention, one of my students is working on a PhD focused on black box brokerage. Now what's black box brokerage? Black box brokerage aims to exploit the fact, right, that you can find code and you can work out whether code is fit for your purpose without being given it. See, if Merobase becomes a trusted broker, right, I can come to Merobase and say, right, here are my test cases. Tell me if there's any code out there that satisfies it, right? And Merobase will tell you, but it won't let you see the code like it does now, right? So we will test it. We can see the code, but you can't. So the point is that you can't misuse the code. You can't get it for free. People want to, you know, especially Android developers, right? Android developers put a lot of effort into developing their little apps, right? And at the moment they can only sell it to the end users. If they could sell their components to other Android developers, that would be another stream of revenue. But they certainly don't want to just make it open source and have everybody exploit it. So, and you've got this problem, you know, how can people work out that something's fit for their purpose without giving them so much access to it that they can misuse it? And black box brokerage through test-driven search seems to be the answer.